right, Hassler here. I wanted to get you started on this lesson because you have toothpicks. And so every one of you should have your own toothpick. You're going to be using those toothpicks to act as tangent lines along your curve. And the idea is that you're going to move that toothpick along your curve so you can see how the tangent lines are going to look different in different parts of that curve. So for example, one says, use your toothpick tangent to trace the slopes of f of x below. And so if I were to do that, if I had a toothpick on this video, which I don't, but if I were to do that, I would take my toothpick and I would, draw it along here, although I'm not happy with that. I would draw it along here. That would be a tangent line, and then here would be another tangent line, and then here would be another tangent line. I get a nice horizontal tangent line there, etc. And so you can use your toothpick. It's a terrible one. You can use your toothpick to help you as an edge. As you're drawing your tangent lines, you can trace your toothpick. And you're going to use that to answer your questions. And so, A says describe how the slopes of f of x are changing over the entire graph. That means that you're going to describe what's happening with these slopes as you move from left to right. We always read graphs from left to right. At which x values is f prime of x 0? So again, we talked earlier this week about what f prime represents. Describe the slopes of f of x as x approaches -3 from the left. So slopes from the left. Same idea, approaches -3 from the right. This feels very limity, etc. Are there x values where you cannot draw a tangent line? Explain. Okay, and then you're going to do the same thing for problem 2. You've got your toothpick tangent. You can use that toothpick to draw out tangent lines. What I think is going to be interesting here is that while we have this curve and we can draw tangent lines to this curve that all look slightly different, when I have this straight line, that slope is constant all the way through. And so the tangent line is the actual line throughout this entire graph. Same idea here. My tangent line is the line for this third section of the graph. And then it looks like we get a little bit more of a curve here happening. This is not quite a straight line. Pretty close though. And so you're going to be asked questions related to this particular graph. Again, are there x values where you cannot draw tangent lines? Explain. Describe slopes as x approaches 5 from the left and the right. What is the slope of the line tangent to g at x equals 5, etc. So you're going to work through. I want the sub to hit pause and give you guys about 7 to 10 minutes to work just on the front page. And then I'm going to go through and I'm going to talk about certain answers on this front page. So please hit pause. Okay, so now that we have decided to play this again, I just want to talk about a couple of things. And one of the things I want to talk about is that this first function is continuous. And because this first function is continuous, we can say that the limit as x approaches any a value from the left of the slopes. So the slopes coming from the left have any x value is equal to the slopes coming from the right side. So as x approaches a from the right, again, f prime of x. And so we've seen this notation before, only not with primes. And so now the new idea is with primes. So I have this continuous connected graph. And what does that mean? That means that this function is differentiable. So this means that the function is differentiable. And differentiable means you can find the derivative everywhere. However, when I take a look at 2, it says, are there x values where you cannot draw a tangent line? Yeah, I cannot draw a tangent line at 4, at x equals 4 and 8, because my function is not continuous. if my function is not continuous, I cannot draw a tangent line, so I cannot find a slope of a tangent line that cannot be drawn. And I really couldn't draw a tangent line here. I mean, I don't even know how I would draw that tangent line. It's two lines coming together, and so it's kind of hard to tell where that tangent line would be drawn. And the same thing down here. I've got these two corners coming together. And so I'm going to say at x equals 3 and 5, and it looks like we have these sharp corners for my graph. We'll talk about those sharp corners here in a little bit. Okay, and so then when I go through and I find the slope as x approaches 5 from the left, so 5 is one of those sharp corners. 5 is one of these sharp corners, and so notation, I'm going to say the limit as x approaches 5 from the left, and we're doing of f prime. So I want to know what are the slopes coming in from the left side of 5. And so coming in from the left side of 5, this is a slope of 2. It's a line, so it's a consistent slope of 2. And then I want to know what are the slopes coming in from the right side of 5. So we're going to write the limit as x approaches 5 from the right of f prime. If you did not write these two notations down, I don't blame you. You did not know to write them down, but you need to get them written down now. Because this, we've talked about notation since the beginning of the year, and this is a notational component that we are now adding, and you are going to be required to talk about the math you're doing. One way to do that is by using this notation. I'm finding the slopes of the tangent lines as I approach these x values on either side. And when I approach the x value of 5 from the right, this slope right here, on this little green line here, is actually a slope of -0.5. And so what can we say? Well, we can say that this is what's the slope of the line tangent to g at x equals 5? Well, I don't know. Those two things aren't the same. Just like with y values, if the y values weren't the same, we said the slope didn't exist. Same idea here. Because the slopes are not the same, then we say that the slope doesn't exist. And so we say, well, the limit as x approaches 5 from the left of my slopes, not of f, but of f prime, does not equal the limit as x approaches 5 from the right of f prime. So we can say the slope does not exist. So slope of tangent line does not exist at x equals 5. Okay. Well, that turns out to be a big deal. So it says, what's the slope of the line tangent to g at x equals 3? And we go through this whole same process again. And so I can't determine. Cannot determine. And the reason why I cannot determine is because the slope coming in from the left side of 3, so I'm right here, the slope coming in from the left side of 3, well, that's a curvy slope. So that slope is changing at every x value. It's not a straight line. Whereas the slope coming in from the right side of 3 is a straight line. It's a consistent slope of 2. What I do know is that these two slopes are not equal. Coming in from the left side, I have negative slopes of my tangent line versus this slope of positive 2. Cannot determine. And the reason is because we have what's called a corner. A corner would be when we get these sharp turns. Or sometimes we get something called a cusp. And a cusp would be like a curve into a curve that creates that little corner. You're not going to be dinged for calling something a corner versus a cusp. In fact, I do not recall any AP questions where they ask you to differentiate between a corner versus a cusp, so that's not something I'm worried about. What they are going to ask you is whether or not a function is differentiable. So it says, what criteria do you think are necessary to be able to draw a tangent line? Well, in order to be able to draw a tangent line, the function has to be continuous. And so we have 3 criteria to prove that a function is continuous. And differentiable. And we're going to define what differentiable means in our notes on the other side. But when I say differentiable, what I mean by that is that the slopes coming in from the left, so the limit as x approaches a from the left of f prime. My slopes of my tangent lines from the left are going to be equal to the slopes of my tangent lines from the right. So I'm writing this f prime of x in there instead of f of x. So that's the criteria in order to be able to determine the slope of the tangent line at any given point. And so if we're ready, we're going to flip this over and we're going to take some quick notes. If you need to pause, please pause or ask for the video to be paused so that you can finish writing that information. Here we go. We say a function is differentiable. And I really think that when you start calculus, you get all these big words, right? So a function is differentiable, meaning I can take a derivative or I can find a derivative. I can find the slope of the tangent line at x equals a if and only if the following are true. If and only if is a mathematical way of saying these both have to be true. It can't just be one or the other. So one, if f of x is continuous at that value. If the function is not continuous, then you cannot find a derivative or slope of a tangent line. You would not be differentiable. And two, if the limit as x approaches a from the left of my slopes is equal to the limit as x approaches a from the right side of my slopes. Okay, so what does this mean to be differentiable? Differentiable means you can find the slope of the tangent line at x equals a. Oops. Got ahead of myself there. Find the slope of the tangent line at x equals a. That's what it means to be differentiable. I can only be differentiable if my function is continuous and if the slopes on the left match the slopes on the right. All right, something else to note is that if a function is differentiable, that means it has to be continuous. So if f of x is differentiable, big words, you're going to know how to spell this by the time you're done. Then f of x must have been continuous. Does not work the other way around. So if the function's continuous, that does not guarantee it was differentiable. But if it is stated that a function is differentiable, then we know that function had to have been continuous because it has to meet that first criteria. That's going to be important. Okay, so you have this check your understanding, and you're going to work through these problems. However, I would like to talk through, not problem 3, but I would like to talk through problem 4b, just so that you understand the expectations. It says determine if f of x is a differentiable function for each function given. Justify your decision. And I just got done saying that in order to be differentiable, the function has to be continuous. So in both of these cases, for A and for B, you need to first check continuity. Okay, and so that means we're going to have some limited space here. We're going to do the best that we can. So the first thing that I want to do is I want to determine is f of x continuous, question mark, and then I'm going to give some space, and if it's continuous, we'll check if it's differentiable. But I have to check if I'm continuous first. So recall the first thing I'm going to do is I'm going to determine the defined point. F of 1 means I'm doing 1 minus 1 squared, and 1 minus 1 squared is 0. Then I have to check the limit as x approaches 1 from the left of my function, and this function is negative 1 plus x. When I substitute 1 in there, I get 0. Looking good so far. The limit as x approaches 1 from the right. So now I'm checking the 1 minus x squared function. We know that is 0. So that tells me that my limit exists. The limit as x approaches 1 of f of x exists. It's 0. And because of that, I know that f of 1 is equal to the limit as x approaches 1 of f of x. And so yes, continuous. Because it's continuous, I can move on here and I can say, is this differentiable? If this was not continuous, then my answer to is the function differentiable would be no. No, it's not differentiable because it's not continuous. If a function's not continuous, I can't draw a tangent line at that x value, which means I cannot find a slope of a tangent line that cannot be drawn. So if the answer is no to continuous, then you're done and you just say no, the function's not differentiable because it's not continuous. In this case, the answer was yes to continuous. So yes, the function's continuous. Now I must go see if the function is differentiable. And so I'm going to show you how to do that. Again, to be differentiable, you have to be continuous, so we met the first criteria. And the slopes from the left have to match the slopes from the right. And so I'm going to check that, and here's how you check that. You say, okay, I want to find the slope as x approaches 1 from the left, and I'm going to do that using the function from the left side. And again, I'm doing this for the slopes, and so I'm really doing, and I'm out of space, I'm going to do this over here. I'm really either doing, you can do limit as h approaches 0 of f of negative 1 plus h, 1 plus h minus f of 1 all over h, or you can do the limit as x approaches that specific a value of 1, f of x minus f of a all over x minus a. I'm going to do that one. I'm going to do that one so I can indicate easily the limit as x approaches 1 from the left. And so I have to do f of x, that's negative 1 plus x, minus f of 1, which we already know is 0, because we found that with the continuity, all divided by x minus 1. Well, that's convenient, because x, negative 1 plus x and x minus 1 turns out to be the same thing. Those are going to divide with each other. Minusing 0 doesn't do anything, and I get a slope of 1. And now I got to check the slopes on the right side of 1. So again, I'm going to use this second limit definition here. And so I've got f of x, 1 minus x squared, minus f of 1, that's 0, all over x minus 1. All right, I have a little bit of work to do here. So I've got, I'm going to say equals the limit as x approaches 1 from the right. So I could factor this. I'm going to do that. When I factor that, that's a difference of squares. I've got 1 minus x, 1 plus x. Minus 0 doesn't do anything, all over x minus 1. But I notice that this factor of 1 minus x and this factor in the denominator are off by a negative. So I really have the limit as x approaches 1 from the right of negative 1 times x minus 1, x plus 1. I'm just going to factor that negative 1 out. I'm doing that so that my factors are properly equal to each other and I can divide. I'm going to substitute that 1 in, and so I get negative 1 times 1 plus 1, which is negative 2. And it looks to me like these slopes do not line up, and so for that reason, I'm going to say f of x is not differentiable. You have to go back and answer the question. Not differentiable, and I know that because the limit as x approaches 1 from the left of f prime of x does not equal the limit as x approaches 1 from the right of f prime of x. Whew, it's a lot of work. Okay, it's a lot of work, but it's what we have to do if we want to check if a function is differentiable. All right, so your job is to do this, check your understanding, check your answers in the back of the packet. I have thoroughly worked out answers 3 and 4A. Same thing with the practice. As you work through the 2-point 3 and 2.4 practices for selected answers. I have worked that out for you so that you can see what is expected, and be ready to ask me questions, or feel free to email me if you have questions.